Problem 3 involves resonance in an open pipe. It reads, the mating call of the Jovian org is produced by a vibrating air column in a pipe 45 centimeters long located between the org's two heads. The pipe is open at both ends. If the speed of sound on Jove is 396 meters per second, calculate the fundamental frequency and the first two overtones of the call. Let's take a look at this org. Here is the org. It emits its mating call. It sounds like this. We're told that the velocity of sound on the planet Jove is 396 meters per second. The length of the open tube is 45 centimeters. We're to find the frequency of the fundamental and the first two overtones in this tube. The fundamental by itself, if we listen to it, would sound like this. The first overtone sounds like this alone. And the second overtone alone sounds like this. All three together again. Okay, determine the frequency then of the fundamental and these two overtones. Here's our open pipe. The length is 45 centimeters, which I have changed to 0.45 meters. We're also given that the velocity of sound on this planet is 396 meters per second. We first find the frequency of the fundamental. The frequency of the fundamental we have just established for an open pipe is equal to the velocity of sound divided by 2 times the length of the pipe, which in this case would be 396 meters per second divided by 2 times 0.45 meters. And if you calculate that, you should get 440 per second, which would be 440 hertz. That's the frequency of the fundamental. The frequency of the overtones, we really don't even have to calculate much. We know that for an open pipe, they're integral multiples of the fundamental. So the first overtone would be the second harmonic, which would be 2 times 440 hertz, or simply 880. The next overtone would be the third harmonic, which is 3 times 440 hertz, and that is simply equal to 1320 hertz. Okay, that's all there is to it. We've calculated then the frequency and of the fundamental and of the first two overtones. Let's move on then to problem number 4.